everyone. Welcome to Beers with VCs, where we have casual conversations about the less talked about aspects of venture capital and startup building. We're your hosts, Sabrina Passman and Simon Lancaster. And today we are very excited to be joined by Jason Stepford, CEO of Atom. He's built an incredible career in the edge and IoT spaces through his experience as CTO for Dell's IoT and edge computing division, VP of Zadata, and now revolutionizing the world of embedded systems at Atom. And he's also a fantastic musician, has amazing guitars, as you guys see. And we are thrilled to have him on the podcast. Jason, welcome.
Yeah, thanks for having me. I joke that they just give all this stuff to you when you move to Austin. Yeah, it's like, here, have some vintage guitars, whatever.
You're full in the Austin life. I love it.
Yeah, I'm always buying, selling guitars, and I have a whole full workshop where I do work on them, and so it's fun. Play music, of course, as well. But good time.
Nice.
So awesome. Okay, well, start us off. What are we all drinking today? I'll go first because I'm the most boring. I have a lychee flavored coffee.
Which,
What?
It's very.
That
it's very
sounds
odd.
awesome.
It's kind of cool.
That's very interesting. Did you add the flavoring, or it's natural lychee flavor? Okay,
added,
like a lychee sweetener pump.
Yeah,
very cool.
Yeah.
Okay, Jason, you want to go next?
So I'm a sucker for a hazy IPA. So I chose a Makana Haze.
Okay.
Obviously play off of tying into Austin. It's a brewery down just south of Austin called Twisted X. Super tasty hazy.
Awesome. I love
say it's all right as
a
Makana Haze beer.
Oh, nice. The challenge. My challenge with hazy IPAs is I usually go for the stronger side, like at least 6, maybe 8%.
Yeah, the Imperial.
They hit pretty hard.
Yeah,
halfway through the podcast. So on that note, today I'm going with a lighter beer. Pub Cerveza looks like a great Corona alternative.
Yeah,
I love their slogan. It's cheap, fun, traditional.
Hey, at least we're not trying to hide
anything.
Just
own it. You gotta just own it. I know. So there it is. Let's have some cheap fun.
Very nice.
I do have a random question to kick things off. With all your background experience in IoT and all those guitars behind you, have there ever been any cool mashups of IoT and music?
Geez, have we done that? Not that I can think of. I mean, short of just using digital stuff. No sensors involved here.
Maybe a cool opportunity for a team building hackathon there.
That's right. Yeah, I need to get on that.
Yeah. So anyway, cheers. Let's kick it off.
Cheers.
Delicious. All right, well, getting right into it, Jason, I'd love for you to give just like a high-level overview of Atom, what you're building, and setting the stage for our audience.
Yeah, so I mean, Atom as a company, the quickest way for me to summarize what we do is I call it Docker on a diet. So if you know of Docker as a technology for putting application containers on hardware, we're like mini-me version of that. And I'll kind of elaborate a bit more. Another analogy I use is if you know VMware, we're VMware Micro. It's all about infrastructure. It's all about how do we make it easier for developers to build applications on very constrained devices. And we'll talk about what that means here in a sec. But I want building on embedded devices to feel like the cloud. I want to be able to move applications from one device to the next. I want to be able to quickly evolve that software. If you look at embedded historically, developing for microcontrollers, we're talking about all the silicon that powers the billions of sensors and cameras and cars and drones and robots and machines and toys and appliances and all this different stuff. It's all like brute force hard coded today. We joke the 90s they want their tools back. I mean, it's been developed the same way for a long time, and it requires very specialized skills. It's very tightly coupled to the hardware, the software. It's hard from a security standpoint. It's actually pretty much how server applications were built in the late 90s before VMware came along, and then virtual machines and Docker and Kubernetes and cloud principles. It's now coming full circle back to the tiniest devices out there.
Totally. So for those that I'm going to abstract it even higher level. for those that are less technical, when you've heard of like cloud being a very big thing in the past, 20 years or so, the main thing that has unlocked cloud and making systems being able to be developed on there is this concept of containerization and this concept of allowing like easy access to different facets of the software. And if you think of an analogy, it's basically like a giant folder system for being able to have all of your clothes stacked and stationed in different areas inside of your dresser and being able to organize it and swap things around in a very easy fashion. The reason why this is really challenging on constrained devices, which is a term that Jason just mentioned, is those are devices that are extremely, extremely small. So your dresser is like baby size.
You throw all your clothes into one hamper.
Yeah, exactly.
And that's embedded, or I call it source code soup.
Mm-hmm.
Everything's all jumbled together. And if you want to make one change to a piece of code, you have to recompile the entire thing and change that entire thing.
Yeah, like take out all your clothes,
take out all your clothes, jumble them all up and put some new clothes in and throw them all back in. Mm-hmm. And that's embedded today. I mean, we also, the analogy is I'm using Excel on Windows. Oh, but wait, I want to switch to Word. Well, I got to re-image my whole computer with Word on it now. That's pretty much how embedded works. Whereas to your point with the cloud, I want infrastructure that I can dynamically load software on. I can reuse microservices of different components. No one builds cloud applications from scratch. They take these components and they mix and match them and add some new code, alongside it. Oh, I want to move it from this cloud to that cloud. Well, with Kubernetes infrastructure and all that, it's like just lift and shift it. It's portable. That's the whole principle. And now we're seeing these principles come to the edge as inherently we need more distributed computing, just by the sheer nature of the data on networks and latency and all that. So it's how can we take the lessons we've learned in the cloud over the past 10, 15 years and bring them back out into the field is what's happening. And we're focused on doing it for the smallest of devices out there.
Yeah, which, as you mentioned, are pervasive throughout like literally everything, any electronic device, basically.
Yeah, mm-hmm. Two-thirds of the footprint of devices out there cannot run Linux and Docker and Kubernetes, all those data center technologies that have become pervasive further upstream. Great technologies, but they're not one size fits all. So we're at Atom, we're taking the principles of that we've been talking about, and we're applying it at a very small scale. So if Docker as a solution, it's an open source foundation. It creates these containers on top of Linux. The Atom container format is 1,000 times smaller than Docker. 256 kilobytes compared to 256 megabytes. So everyone's like, well, everything's getting more memory all the time, like all these devices. My phone's now got like 8 gigabytes, 16 gigabytes. My computer's got whatever. It costs money to have memory. I mean, you might notice you go buy an iPhone and how much more money that you pay just to have that extra memory. So it matters to be able to develop with these containerized applications, modular, make it easier to develop, software in general in a very lightweight footprint.
Which, to your point, like even though memory's expanding, it is expensive. Like having smaller memory footprints is applicable not just for really, really tiny devices, but also big devices that need to save money. So it's applicable for so many different facets of industry right now. And you've touched upon a little bit the history of like going from embedded systems were kind of like pervasive from 30 years ago. Cloud became a thing, and now you're applying the principles over. You've been in this industry for basically your entire career, and I'd love to kind of walk through the stages of this evolution, and also at what point in time you realized that this opportunity for Atom was truly something you wanted to spend like a good chunk of your life doing moving forward. Can you walk us through like your early career and how you got to this place?
As I call it, the magical mystery tour. Yeah, I mean, I have a lot of mottos, and one of them is if it's fuzzy, I'm on it. I always find myself on the fuzzy front end of new technology trends. I've been in CTO roles and R&D roles a long time, engineering background. But I started on the whole, IoT trend in 2014, 15. When I was at Dell, I was in the CTO org, and a small group of us drove the initial strategy, for the executive team at Dell. What do we want to do with this buzzword IoT? We decided it makes sense for Dell to build these industrial grade, PCs, sort of get into that side of the embedded space. But ultimately, I went off with the team and looked at the software strategy. Realized super quickly the last thing the world needed at the time was another IoT platform. Way too many. Joke was like there's 150 or something back then. This is 2015. Mm-hmm. Then a couple of years later it was 400. A couple of years later, a lot of that's kind of scaled back. And I think we'll touch on that as we go, just in terms of what's important out there. So that was actually when I first started getting into this idea of like the importance of open infrastructure. And so early in those IoT days, looking at the software stacks, we were coming out of the machine-to-machine days. Everything, it was actually kind of similar transition as to what we're faced with right now for Atom, is monolithic machine-to-machine, early days of IoT stacks, but then they're trying to be repurposed for the new wave of IoT that was the hot topic in that time frame. And we're looking at it as like these architectures are super rigid. So we started developing internal to Dell. What does it look like when those cloud principles start to come out into the field? So in 2016, we started a project within Dell that's ultimately became EdgeX Foundry within Linux Foundation. So that is a application framework for IoT. How do I plug sensor connectors into cloud connections and local analytics? So it's in the application plane. And the idea was to go drive a standard around that in Linux Foundation. It's now globally used as a project. I didn't know anything about open source before we started that, but we decided way back then the last thing the world needed was another IoT platform. So let's go try to democratize it a bit through open source. So got that started with the team there, and then started looking at the infrastructure below that. So there's the application plane, and then there's the infrastructure below. A lot of folks were like, oh, we'll just take the principles of the cloud and Docker and Kubernetes and Linux and just shove it on out there, into the field. By the way, we called it EdgeX Foundry, like forecasting, it's a playoff of Cloud Foundry, which was initially, kind of the big thing when the cloud was being developed. We added the X so it could be trademarked, but I had a bunch of people in certain camps trying to get us to call it Fog Foundry, because fog was like a term. I'm like, no, Edge is going to win. We're not doing that. Fortunately, it went our way. But so we start looking at what happens when I get out of a traditional data center, and I want to use those principles, but now I don't have a secure network perimeter. Someone could walk up and touch a box on a factory floor or out in an oil rig somewhere, or stuffed in a retail closet, store closet. And, I'm at Dell Technologies, CTO for Edge and IoT, and working with a lot of really good people. A lot of my colleagues were VMware employees, and clearly VMware, led a lot of this, when it, kind of turned into a data center, and then of course the cloud, changing how things are built. But it's a bit different when you get out of the data center. So my team at Dell was working on what that looks like. Turns out a company called Zedita was implementing that vision. So I left Dell in 2019 for Zedita, and Zedita I call like VMware Lite. I'm out of the data center, so I need a very robust zero trust security model. I need to assume I'm going to lose connection to my controller because I'm out in the middle of nowhere in a mining facility or whatever. But I can still run Linux, Docker, and Kubernetes, those technologies. So that was the next click down. Did that for 3 years, worked on the executive team, really great solution. And then I needed a change. I left Zedita, took a couple of months off. It was glorious. Thinking about what I wanted to do next, I had this opportunity to start Atom, or kind of help shape the formation of Atom with my co-founder, Stephen. And it really is, as I call it, the last stop on the magical mystery tour. It's like, so I've ridden this from like cloud down to data center to what we would call the distributed edge, past the Linux barrier to devices that are so small they can't run any of those technologies. And
what's that barrier called?
The barrier below that, your airbag. You do not. You want to hard code your airbag, in your car, like anything that's, we go down as far as a very lightweight device, about a meg of memory, because our footprint is 250
Dang.
kilobytes. Below that, you use like
So cool.
a super lightweight processor doing like your airbag. Hard code that. That just you're not. It just wants to do one thing really well.
That's right.
But there's so many other things that are becoming more software defined. As we go.
Do airbags actually have microcontrollers in
Oh
them?
yeah.
Oh dang.
I mean,
This is why I'm so excited about like what you guys are building, is because like microcontrollers are literally everywhere now. And
you look at a car. A car has almost like probably 100 of microcontrollers within it for everything. And so take the analogy of a car or a robot. So we were talking about how embedded is like brute force, monolithic firmware. If I change one thing, I got to wipe it out and put the new image on. Well, now go try to build a car with all the suppliers coming from different places, and they have these interconnections. And if I change something in this system, then it impacts this system, and everyone has to coordinate it. And then the customer, has something that breaks. It wants to feel like the cloud, where it's this dynamic, continuous delivery of software. Everything's tied together with APIs, or kind of these boundary conditions. So that that's what we're going to enable.
Yeah. And that's why, specifically inside of the car example, like when there's a software issue or software updates can be uploaded obviously via cloud, but if there's like something wrong with a fundamental hardware sensor that is like locked as an embedded system, can't be updated via cloud, basically you have to recall the cars and you have to like go back to the factory and reservice everything. Or if you have a new product line, like you have to start from scratch, right? You have to like all of the surrounding components that are affected need to be completely redone. It's years of effort in some cases, particularly for automotive. And it's a huge...
Yeah, it's across the board. I'm sorry.
No,
you look at during COVID, when the silicon supply chain was just wiped out and car prices went through the roof. A lot of it was because people couldn't get parts. And embedded, the software is so tightly coupled to the hardware, just like it used to be in the server world. But now, like you can literally lift, VMs or containers off of this machine and put it on this machine, and like with the click of a button. Used to not be the case. But in embedded, so say I take a microcontroller that's an ARM architecture, but it's branded NXP. And I can't get NXP parts, so I want to switch to an ST Micro part or some other brand. The way it's done today, it could take 3 months of time to unravel all of that hard coding you did and the tool sets and linking libraries and all that to that silicon, even though it's the same architecture. With what we've done, because we create this hardware abstraction layer, just like VMware does for servers, or Docker does, in the general Linux sense, 3 days. Of just switch. Ultimately it could be where you write functions and they could run on a microcontroller or on a switch, a gateway, a server in the cloud. I mean, our focus is on constrained devices, but the format we're building is more universal.
Yeah.
It's the idea is start with the lowest footprint you can possibly go, and then you can go anywhere. The data center and cloud technology is coming down, like Docker, Kubernetes, Linux in general. Great technologies, but there is an inherent like hard stop, and that's what we call the Linux barrier, at about 256 megabytes of memory. That is the floor of what's required to run Linux with Docker. And again, we're 1,000 times smaller than that. So you can imagine the new places that you can go while getting the same benefits.
I'm really curious. So this is a question kind of for the founders in the audience of like, your product is revolutionary in so many different ways. You have so many different verticals that you could tackle as a CEO. How have you figured out how to prioritize your go-to-market? And
yeah, and it's obviously an important one, and it's especially tricky when you're a horizontal infrastructure technology. Yeah. You could go anywhere. So there's a variety of lenses that we look at. First off, it's this spectrum of OEMs versus end users. So an OEM would be I'm building a connected product, could be a sensor, a camera, a drone, a robot, whatever, and I'm selling it to my customers. They're the ones that are building stuff with microcontrollers and constrained CPUs, and they're building like unique form factors around it. An appliance is a little bit different than a sensor, which is a little bit different than a car in terms of form factor. So they're building these products that end users use. So that's one spectrum of our go-to-market. And the other one is end users. I am a retail chain and I'm buying smart cameras off the shelf, and then I would buy Atom like I buy VMware to deploy machine learning containers on the device for like safety and security or customer experience or whatever. So that they're actually doing the work as an end user. So we're focused on primarily OEMs that are building connected products, like selling to them that then they sell to their customers, but there's also an end user play. A second lens would be, why would you care, about us? And so there's a couple different, core things. So I call them lowercase use cases versus uppercase, which is like quality control for, production line or whatever. Like lowercase use case would be big value add for us is reducing engineering friction. This challenge that you have when you want to change one thing and it compiles, you have to recompile and it affects everybody else downstream. I have to share raw source code with other people, like including partners, to be able to collaborate, which exposes my IP. All these, switching silicon, vendors, all these things that are challenging. That's a big reason why we're having people come to us. Just make embedded easier. Then there's help me with security. A lot of embedded today, like a lot of consumer products, very little security applied. People don't want to update those devices in the field because if they do, it might break. You might have experienced that if you've ever done anything, IoT within your house, or and then they become an attack surface. But so we make it easier to kind of modularize and abstract apps from a security standpoint. And then another small, lowercase use case is anything attached to AI on device or machine learning. We're seeing more and more intelligence being embedded into products, like for computer vision or video sensing, audio control. I mean, you look at an Amazon Echo, hey Alexa, that is a microcontroller running inside that is listening for that wake word, and that's what turns on the internet connection. Now imagine you wanting to turn that into all the different things that you're asking or interfacing with. Those are all machine learning models that then learns over time. And it's a symbiotic relationship between that device with intelligence and the cloud. And so when you're doing intelligence on a device, it can't be set it and forget it and cross your fingers you don't have a security problem like it used to be. You have to keep updating that device because that machine learning model is going to evolve. So that's another lens. So summary, like reduce engineering friction, increase security, add intelligence. Now I have to evolve the device. And then the last reason people would want to use Atom is I need more space. So while we make it possible to run cloud principles and containers on very tiny devices down to a megabyte of memory, microcontrollers, another area where we're seeing a lot of interest is like OEMs that build network switches or set-top boxes, or we're even getting asked about phones. Because if you look at Linux with Docker, so a network switch provider, historically it's embedded Linux, and it's optimized to do one thing, which is switching network traffic, and memory optimized because it's a BOM cost. It costs money. But what's happening is people want to Dockerize or containerize these network switches so they can add new types of functionality, even machine learning for threat analytics or whatever. But if you use Docker with Linux and you have, say, 512 megs of memory on that box, max, Docker with Linux takes up a half of the memory just for the foundation. Imagine your house, if your concrete slab was like half the thickness of the whole house. That's basically Docker, today. You bring in Atom, with our solution, and we're leveraging WebAssembly, and we can talk tech, whatnot. Like there's much of cool stuff we're doing, but it's like a sliver but gives you the same sort of experience around containers. So the last reason people would be interested in what we're doing is that if I'm hitting resource constraints on even more capable devices, you get into like big, class servers and whatnot, you got plenty, of space, but in that, kind of 512 to a gig of memory, those types of edge boxes, it's super valuable to just get the space back. So the net is devices from 1 meg to 1 gig of memory is our focus area. And then the last lens, of course, is verticals, and we're very focused on industrial, predictive maintenance use cases, anything around computer vision for quality control or safety. Retail experience is another option, but also consumers fair game. I mean, there's just so many different connected products that are increasingly intelligent that also need to do a better job at security. So, we've got a lot of kind of specific things we're doing to kind of tailor the markets that we go after, but a lot of different. There's no shortage of opportunity. I'll say that much. We just have to be careful.
Yeah, I mean, the number of places that you can target from a customer standpoint is extremely impressive, and honestly, like a little bit overwhelming, I think, for any like CEO to figure out how to like navigate from
We have to be careful.
hierarchical standpoint. Yeah, because you can really go too wide and then potentially spin your wheels in different areas and not get the fastest ROI. And I think the goal of any startup obviously is to grow as efficiently and scale as fast as possible. And I think you're taking a very intelligent approach to this. It's one of the reasons why we've been so excited to be working with you. And I think that you've mentioned you have a secret Trojan horse that you're working on to help enter different organizations. Can you tell us about your strategy for doing so?
Yeah. So I mean, I'll kind of articulate a little bit on the solution, and then we'll at Atom, what we sell is our orchestration hub. This is what it's SaaS by default, but it also could run on-prem. It's it's basically an enterprise application. I am in DevOps. I'm the administrator. I'm managing fleets of connected devices out there. That's where I go in and I manage the device. I understand the health. I deploy applications. It feels like Docker, even though it's not Docker. We've followed the paradigm as closely as possible. But so that's what we sell, but it's enabled by on device. There's a runtime. I mean, you can think of it as an operating system. That's what sits first on the device. It replaces your traditional firmware, and then the containerized applications sit on top. It's a lot like VMware's vSphere that runs on a server. It's this abstraction layer. So now as a developer, when I look at a tiny device, I'm not seeing like lower level GPIO and SPY bus and all these. I'm looking at APIs or interfaces. Like in your phone, an app developer doesn't make calls down to the silicon for the GPS. They ask for, where am I? Okay, well then I feed that into the app. That's what we turn devices into for developers. That runtime, the core of it, we've donated to the Linux Foundation. So as I mentioned before, I've got a lot of experience working with the Linux Foundation, driving open source projects, working with other standards bodies. So we've donated the core of the runtime component to the Linux Foundation as Project Ochre, the Ochre runtime. So think of it, think of that as like mini me Docker, or Docker on a diet, as I would say. It's part of LF Edge, which is right next to EdgeX Foundry, which I worked on with the team like way back when, which is right next to Project Eve, which is Zadita, my former employer's their base, which is suited for kind of the next tier up. So it's it's all kind of come together. But Ochre, the whole point there is to make it a standard, to go drive a de facto standard through collaboration with the community, and that reduces risk for people to adopt this technology. Ochre leverages standards. We're not reinventing anything. We're gluing it together. It's leveraging WebAssembly as a technology, which is very hot in cloud native. It was initially developed for the browser, but it's now making its way into new places. It's big in the Kubernetes world right now. We're starting to see, we made a bet on this about a year and a half ago, 2 years ago, which it's on trend. But we're now seeing people talk about how WebAssembly is likely to replace Docker, as that ubiquitous put functions anywhere as a virtualization technology. So it's WebAssembly. We're leveraging a real-time operating system called Zephyr, which is also part of Linux Foundation. Really big community there. Tie all that together, glue some extra stuff around it, create APIs, donate that to Linux Foundation, and then we pull that back and use it with our hub, which is proprietary to us. But anyone could go download, Ochre and do whatever they want with it. But generally speaking, if you value your time, you'll go work with people that have commercialized things and go focus on applications and domain expertise and whatnot. But that is our way of building trust with OEMs over. If it was Atom as a tiny little company with a proprietary infrastructure stack that if you use and we disappear, you're starting over, it's not really attractive.
Yeah.
So it provides a buffer of that investment in that technology. But we just make it easier to use. And we have some proprietary enhancements in our console that helps with performance and security, around those end devices. But anyone has to be able to just go download Ochre from GitHub and play with it, contribute to it, whatever.
Yeah. So I want to double click on a couple of things that you said. First is that you are using WebAssembly, which is a platform that people can contribute to in an open source type fashion that is unlocking the, basically it is replacing Docker because it allows you to build in a much smaller footprint. But in order to contribute to that in a very easy fashion, there's a big open source play that you are leveraging to actually help accelerate your business model. And I'd love to double click on the open source risks and benefits for the type of program that you're building. Because you're doing a platform that is enabling so many different types of builders to create, it makes a lot of sense to have some foot in an open source platform that you've actually helped seed from the get-go to allow many different types of developers to contribute and fortify the code base. This is actually really counter, though, to the typical deep tech mentality. This is something that I want to kind of shed light on. Mostly in deep tech companies, people are very careful about their moats. Like the reason why you would, a VC, for example, would invest in a deep tech company versus a generic SaaS company is because there's a technical moat built in that makes it very hard to copy. And that's why you can spend more money when investing into deep tech deals without fear of the competition kind of engulfing everything that you've been building. Open source seems completely contrary to that mission. But in reality, given the fact that you're an architecture play for embedded systems, it actually is really crucial to the strategy. Like, can you walk through how you're strategically leveraging the open source inside of your business model?
Yeah, I mean, there's a lot of misconceptions, I think, about open source, and there's a lot of reasons to have proprietary components of your solution. This isn't about people think a lot of times at surface level, oh, you just donated everything to open source when you're talking about an open. No. Mm-hmm. You donate and contribute and collaborate on very specific things for very specific strategic reasons, that also benefits, others. One of the things I would say is open source it's float all boats, and then you make sure your boat's really good and really fast. You have to just keep up. You win by merit, not by lock-in. Mm-hmm. And so we've at Atom, we're doing a lot on the proprietary side with our hub. We're using the open APIs, but we are investing in IP and actual patents around our version being really compelling. But that open component, we've done enough to where it builds that confidence and trust, in the field around. Now the counter is you do Docker, amazing technology, but it was actually the opposite. It went 100% open community up front with no business plan, and Docker failed as a company.
Yeah.
So you want to start as an enterprise, figure out kind of what makes sense to kind of meet strategic needs from what goes into the open source world versus what you keep proprietary and your own differentiation, and then you carve that off and you work and build a community around that. You don't just go throw some code out there and be like, all right, now how do I go make some money? It's kind of the opposite, but there's this misconception that if I go open core model, there's no way to differentiate. I don't think that's really accurate. It's less secure, not accurate. There's a lot of studies around there that open source software is actually in many ways more secure because you have a lot of eyeballs on it, and there's transparency, and the SLA to get things fixed is really fast because you've got a lot of fingers on keyboards. But that's also why you work with open core companies, because those commercial models buffer you as a customer from any churn, or at least that's the intent. I manage revision control for you. So like we're working in the WebAssembly community. We're co-chairing a new interest group with a number of other companies like Siemens and Bosch and Intel and a bunch of companies around standards and recommendations for WebAssembly for embedded. We're then putting that and saying, hey, we're going to codify this into code that you can run in Project Ochre within Linux Foundation. And customers that we're talking with are like, love it. But as this changes, am I going to, no, we will buffer that for you. And at appropriate times we'll evolve, that golden version of the code here. And then there's actually a new effort called Margo within Linux Foundation, where we're then taking that code and putting it into the broader continuum, working with a bunch of other companies like Rockwell and Schneider and Emerson, and Emerson, who's a co-investor along with you guys. We've been doing some really cool stuff there. Like it's about creating these right kind of footprints in places, creating the right ties between them, but then also appropriately carving off and having a strategy around what's open and what's not. Mm-hmm. And so it's as long as you think it through, it's important. And there's, for us doing infrastructure, I think you just have to. I mean, not attractive as a big company or even a small company to bank on a proprietary technology that, if they disappear, your rug pull out from underneath you.
It's interesting, Jason, like the way you just described it actually made me reminisce a lot about IP patent strategy. So I don't have nearly as much open source experience as you, obviously, but I have a lot of IP and patent background experience. Very well-rounded background in that space. So in that area, basically, I mean, you can think of patents as kind of like time delay open source. Like that's literally their definition, right? You're publishing everything, you're sharing it. It's like old school open source, but you get some period of exclusivity, right? Like 20 years or whatever it is. Even with patents, right? Every startup is going to have a particular strategy, or they should have a particular strategy where they file patents, but you won't always want to publish everything in your patent. You want to keep some stuff trade secret, some stuff actually not published. And it's really that balance of like, what can we protect through one method versus what do we want to keep closer to the chest and protect through another method? I think it just sounds like there's some interesting analogies there.
It definitely. Well, actually, so we've got 2 additional patents, pending around our value add on top with our orchestration hub. When we formed Atom, we had 2 patents actually issued based on prior, kind of history of us bootstrapping it. One of them is basically what's in open source now. It's broad claims around all the stuff that you do with Docker and Kubernetes and all that, containers and hardware abstraction layers, but on a tiny device. We still own the patent, but strategically it made sense to sort of carve out a portion of that into the open world, to make it a standard. And then, I mean, just in general, like there's so many resources that people pour into software development, reinventing the wheel. And I would call it, I picked this up a long time ago from somebody, undifferentiated heavy lifting. Just pouring money into reinventing the wheel on stuff that just doesn't matter. Where you make your money is on I call it the IDIs: security, manageability, usability, scalability, and commercial support around all of that. It's not on the bread and butter necessarily. I mean, you want infrastructure companies like Atom to go do that, but you want it done in a way where it's transparent and trusted.
Definitely. So there are. So in terms of the undifferentiated heavy lifting, I think that really closes the loop in terms of like the benefits of like choosing to do an open core. I think that there's a lot of companies that like there's basically two strategies when you're building like an infrastructure company, I suppose. You could either have everything completely closed, close to the chest. You don't share any of your learnings or anything. What that limits is that you don't have strong feedback from multiple different customers, which means that you're basically building your product for only one specific customer at any given point in time, which really limits the ability for you to scale. Whereas if you choose to open source it, get feedback from multiple different partners, and be selective about what actually you're sharing and what they can contribute to, not only does it build trust within all of the customers that you're trying to attract to your company, because they can see everything, they understand all of the different nuances of what they are signing up for. And they have the security that they can always fall back to the open source code if when they decide to progress to open core. And so the option for leveraging an open core model allows you to build trust, allows you to have better product market fit because you have more companies that are able to see and contribute to the code base. And then also, as you mentioned in your analogy, be the fastest boat regardless. And so you have all of this open source, this lake that you've distributed for everyone to ride on, but you still have the core value proposition with your proprietary IP that allows people to still see that Atom is the true winner inside of this space. And so it actually is. I like the idea of it kind of being a Trojan horse, because you actually are giving it's all positives, honestly. Like you're giving them more security, you're giving them more trust, you're giving them flexibility to feel like they can switch at any time if they want to, but you're obviously still the best boat on the lake. And so therefore you can still actually be the fastest one.
Yeah, it comes down to I want to know that I can switch if I need to, but it's not worth my time to rebuild something that I could focus on, value add for my customers otherwise. And here's a couple other analogies. So look at building closed source, especially big infrastructure ecosystem plays. It's very capital intensive. Mm-hmm. So VMware comes along at a time, late 90s, kind of evolves quickly into the server, virtual machine abstraction layer. 100% proprietary, still is. Changed kind of how server software is developed. Starting to struggle now. Why? Mm-hmm. Because Kubernetes comes along, and is another way to build, clustering and abstract applications. In this case, they're containers, and it's part of those clusters. And Kubernetes, it's open source. It's part of Linux Foundation, part of Cloud Native Compute Foundation. Google donated it 2017 timeframe. Crazy explosion. Yeah. But DIY Kubernetes, go to GitHub and download Kubernetes and start trying to build your own clusters and all that. It's really painful. So you still want, commercial help, but it helps to kind of create that base. Another analogy I would use is this whole notion of like the moat. You look at Apple, and this is from someone that has a bunch of Apple products. I'm talking through a MacBook, it's all good. But if you look at the market, Apple's, walled garden, very curated, great experiences, but less choice. Mm-hmm. Android, rooted in open source, ubiquitous. I don't know. Most people don't know that 90% of the market is Android, even though, a lot of people that have Apple products. And there's a reason for that. It's because of, open source build scale. Now, there are trade-offs. But it's just, as we're saying, you just have to find that balance between, what's open and what adds value that's proprietary. Mm-hmm. Oh, but also Apple spent a lot of money to get to where they're at, so it's over a long period of time. So if as a startup, it's a very important choice as to how much you want to take on, because it's so capital intensive to create that moat. And just, I would recommend to be careful about, are you building a moat around something that doesn't matter to protect?
Totally.
Yeah. In the realm of getting customers and building the trust within the industrial scale companies, again, this is a question for like generic founders, like trying to attract larger scale customers. It's very common to get stuck inside of what we call at Omni pilot purgatory, where you have a first promise of very strong alignment between the customers. They're both excited to build. And then suddenly you're stuck in this cycle of like continuous
Yeah,
builds that don't actually
I call
convert.
it the POC friend zone.
Yeah,
You can't get past the friend zone.
exactly. Do you have any tips, or like, given all of your experience so far, how have you strategized to avoid the friend zone? How do you get past that?
It starts with no free POCs. I mean, giving like a small taste is cool, but I mean, when I was doing the early IoT stuff, like, you know, I was working with a bunch of big companies, all these subsidized free POCs, you know, and no one's going to value your time if it's free, and, you know, kicking the tires, like, but not having any skin in the game. It doesn't have to be much. And the alternative to dollars is people that are, you know, accountable for it, you know, on the receiving end. But it can't just be like you pushing on it and them like, you know, agreeing to, okay, fine, let's do a POC, but there's no, you know, nothing, you know, exchange that's meaningful. I think a lot of it starts with knowing your customers, you know, and the reality of it. Like, it's easy as a startup to be like, anyone with a pulse that's willing to get on a call is like a customer. Not really the case. And if you find yourself having to pitch to somebody and they don't even have a use case or even really understand the value of what you do, obviously you do not go try to do a POC or force one. The other thing that I've found that's helpful, and especially when you're, you know, I mean, we're an enterprise company that also is, you know, very developer centric, and we've got the open source component. You have to create other paths of discovery. So for us, if you want to pay for help or like pay for a POC, or we'll do integration with your system, because a lot of times people will white label Atom with, you know, kind of behind their bigger offering. Great. If you want to just get information and tinker, go to Ochre, go download it from GitHub. If you're not willing to put the time in there, why should I put the time in, you know, in here? So one path is like, you know, go experiment. And if people are passionate about it and have some initial ideas, then they're going to probably find their way to the Atom developer network, where it's still best level support on our part, but we have more structured content. You get access to a freemium version of our console, so it's easier to use. You get the easy button, you know. So now, but it's still sort of self-discovery. And then the next stage is, oh, you want us to get hands-on? Well, then we're doing a paid POC. So you've got to get out of the middle of the initial discovery and set up processes so that you get engaged when people find value and will pay for it.
Yeah.
So
and even another benefit for the open source component, like, you can basically filter out the crappy customers through that if they don't even have the bandwidth or the mentality that they want to like use the open source and then push through. Just like, oh, there's applications on top of this that I want to build. Yeah. Then, you know, automatic filter.
I will say though, so this goes back to that kind of some of the myths around open source. Mm-hmm. If you look at Zadita, my former company, and we're like mini-me Zadita, you know, that next click down, I would say the majority of their customers initially found them through open source, Project Eve and Linux Foundation. They were looking for a solution that existing technologies didn't, you know, apply to. This out of the data center, but I need a different security model, a different approach. They could have just used EVOS and went off and developed their own console, but all of them was like, hey, Zadita, can you help me with your console and help me, you know, harden this and do all that? That's not worth my time. But I appreciate, you know, this open source component. And that's the key thing, is it's a really good discovery mechanism. Have that initial conversation in that open forum, get comfortable with it, and then enter into the commercial discussion. And I've got all these little things. There's a lot of time burglars out there. They just steal your time. And so you want to focus on you have mechanisms to kind of weed that out as much as possible, but then also be ready to dive in when it's appropriate.
Mm-hmm. Mm-hmm. There's a lot of really good nuggets for all technical founders. So, as of course, like, you know, we are deep tech VC, and I think the struggle of finding the right customer and how to vet them appropriately, how to make sure you're spending the right amount of time with them, that is like the hardest thing to get right, especially when you're starting out. And I love all of the things that you've baked into your business model at this point allows you to filter out customers appropriately to make sure that you're spending time where you need to and not, you know, wasting it with frivolous customers. So huge kudos to that. Really excited to share these learnings with the community at large. There's another piece to Adam that we also really love, which is just the team in general. Like, you are stellar, Steven, your co-founder, is stellar, and I would love to just click on how you guys met, and any advice for our founder community around how to find the right people to attract to the team and the vision that you're trying to build.
So my
That's a great one.
recommendation is dumb luck.
Unfortunately,
There is something though about surface area of luck.
If you're I mean, we'll talk through some stuff, but ultimately there are ways to inadvertently feed serendipity. And so, like Steven, he's great, and we've built a really good working relationship. We've been working on kind of building up and forming Atom over the past about year and a half, but I was introduced to him right then, and we've been like probably 1 degree or a half degree of separation for like 10 years, working in similar areas. I joke, Kevin Bacon, the 6 degrees of separation, he like completely failed with Steven and I, because we never got connected. But he's been, he was at Schneider Electric for a long time, Microsoft, a bunch of different areas that are complementary to kind of my history, and we work well together. And it's funny too, because I've come from a CTO background, and Steven's our CTO, co-founder and CTO. When this opportunity came up after I left Zedita and we met each other, I'm like, well, I never really thought about being a CEO before. But I mean, I've got plenty of leadership experience and whatnot, but I'm like, well, a CEO is really a CTO plus all the stuff you don't want to do, like HR and fundraising. I'm like, well, I can do that extra stuff too. So it's cool. But, so it's, part of it, is obviously surrounding yourself with, good people, have an opinion and being willing to share it. I think it's important, just have a reference point, but then also value people that have other opinions, I think is important. There's this whole kind of, network effect thing.
Absolutely.
I'm a huge fan over the years, and this is also what leads to the inadvertent serendipity, is help people out without expecting anything in immediate return.
Yeah.
In terms of advice,
this is the surface area of luck thing I was mentioning.
Yeah,
you can actually increase your luck by doing that. Yeah,
it tends to come back and pay you back. Pay you back in spades more often than not. But it's, I've said also for a long time, the best way to get a job is to already be doing it. Just go fill gaps. I mean, if you ask, this isn't about like stepping on people and all the politics stuff. I'm anti all of this stuff. I can just, but if you see a hole, if you ask to fill it, you give someone an opportunity to say no. So just go do it. And then they can't imagine you not doing a really good job at that. And so that's all the kind of stuff, like in terms of, finding co-founders, I think a lot of it is doing these types of things on an ongoing basis enough to where when it comes time to find somebody, you got a Rolodex. And you've got a Rolodex of people that complement your own abilities and whatnot, and some dumb luck.
All the above. Yeah.
All the above.
It's the impact of other people in building anything it can't be understated. I think there's also a strong perception, especially within like the deep tech world, that you got to pick the smartest people that you have met in your network, and that are all relatively monolithic, and you guys all think the same way, and that's not the way to run a successful business in any capacity. No. And I think the fact that you guys have similar technical understanding and experience, but also diverse backgrounds from and skill sets, honestly, in the way that you're able to run the company is incredibly helpful. And I agree with Simon's mention of increasing your surface area of luck and relying on a little bit of dumb luck, but the way that you keep reinforcing that over time is you keep contributing to the community in meaningful ways in different facets. And then from there, it'll kind of snowball into something that attracts a really strong team. So huge kudos to everything that you've done at Atom, Jason, and really, really impressed and proud to be alongside you in this journey. I think I have one final question for you before we wrap up today. And that question is, in your whole career so far, who has been the most impactful person and why?
I mean, that's tough because there's so many people I've worked with over the years that have influenced me, and great bosses, some not so great, but but whatever. We've all been there, but really fortunate. But what I think of is my very first job. I'm a mechanical engineer. I've gotten into software and all that stuff and business side of things. But I went to UT here in Austin. I've been here like 30 years. Out of school, I go work at Dell. I was at Dell and then at startups for a while, and then went back to Dell when I got into the IoT stuff. But my very first job in the mechanical engineering group there was, he said one day, it's like, when you're kind of trying to figure out what to do, don't run away from stuff, run to it. And that stuck with me of like, it's kind of like, the best way to get a job is already be doing it, and just kind of going to have an opinion and, whatnot. It's because I hear about a lot of people all the time. They're like, they complain about their job. I'm like, I don't have any sympathy. Just do something about it. I mean, people have different circumstances, of course, but that one statement stuck with me, very early on. And it's, I mean, many other, I think, very influential people, but it did stick with me.
Yeah, I love that. We should cheers to that one. Something to remember.
Yeah, this is the telltale sign that this podcast is over. I'm out.
We've done it.
Oh yeah, cheap fun.
Oh no.
Truth in advertising. All right.
Yeah, amazing. We've really enjoyed it, Jason. So if people want to find more about Atom, where can they go?
So yeah, go atom.io. You can go to our main website. There's information there. You can reach out to us, through the contact form there. The open source component that we talked about, Project Ochre, you can find that within the Linux Foundation. Just type in OCRE Linux Foundation and you'll get to that page. Go to the GitHub, download it, have fun, get some, what is it called? Cheap fun and start coding, but if you need commercial help, you want kind of help getting started, come to us. We wrap all the goodies around it. And, it's all about going to help people scale out their infrastructure for very tiny devices. Love it.
And also you'll be at Embedded World.
Oh yeah. So it's the first time in Austin or in the US ever. In North America. Usually it's in Germany, and it happens to be in Austin. I mean, I'm like just south of downtown. I can see the convention center from our house. I'm like, get on my bike and ride up to Embedded World. It's like, I think the 8th to the 10th of October. Awesome. So yeah, if you're at Embedded World or whatnot, reach out. But reach out regardless if you're interested in learning more.
Love it. Thanks so much, Jason. We really, really appreciate your time, and thanks for sharing all your insights.
Yep, thank you.
Mm-hmm. Simon, you want to sign us off?
Thanks so much.
Yeah.
Sure thing. Thanks, everyone. This has been Beers with VCs with Jason Shepard. Cheap fun. Have a great day. Bye.